And next we look into display devices. So next up we look into what is the computer graphics and what are the application of the computer graphics. So now we can discuss the display devices. So display devices, also known as output devices. The most commonly used output devices in the graphic system is a video monitor. So what are the types of display devices? CRT, random scan, raster scan, color CRT, DVST, flat panel display, and plasma panel displays, and LCDs. Now, CRT. What is CRT? Cathode ray tube. Okay. See, a CRT is an evacuated glass tube. An electron gun at the rear of the tube produces a beam of electron which is directed towards the front of the tube, that is by the high voltage. So we are using the electron guns, that is the rear of the tube produces beam electrons which is directed to the front of the tube. So whenever we are to form the electron beam, the electron is directly it will be form of the glass tube, then it will display the uh, display the image on the particular screens. So in the electrons are with the high voltages. So the inner side of the screen is coated with phosphorus substances which gives off light when it is broken with electrons. So all the electrons will go from the directly, then in that way we have to define the particular inside the screen, that is the phosphorus substituted codes, then it will be displayed display the image on the particular screens. So the inner side of the screen is coated with phosphor substance which gives off light when it is struck by the electrons. Next, here is the control gate. That is, the control gate voltage determines the velocity achieved by the electrons before they hit on the phosphor. So it will be assumed that for particular velocities before whenever it will be transferred the electrons, then electrons will be hitting the phosphorus. It will be used into the control gates. See, this is the cathode ray tube. See here, connector. These are all the connector pins. This is the base, focusing system, vertical deflection plates, horizontal deflection plates, electron guns, electron beam, and phosphorated screen. See, here the electron gun produces all the electrons. It will be go from the focusing system. The focusing system defined. So all whenever we have to produce the electrons, all the electrons will be displayed at the time. In that way, the focusing system taken one by one, and it will be produced the these plates, that is the vertical and the horizontal plates, then it will be transferred and it will be hit into the phosphorus coated screen, that is the inside of the screen, phosphorus coated screen, then it will display the image on the particular screen. Okay, see here the electron gun produces the electrons. That electrons will be at the time it will display all the electrons. In that way, the focusing system maintain the on the way of the electrons. It will be one by one, and it will move into the horizontal and vertical. Then it will be form the electron beams or will be hit into the particular phosphorus coated screen, then it will be display the image on the particular screens. Okay, this is the cathode ray tubes. So this is the phosphorus coated screens, and these are the focusing system, and mainly we are using the focusing system, and these are all the different type of the plates. There is a different type of plates. There are two types. The first one is the horizontal deflection plates, and the second one is the vertical deflection plates. So likewise, we have using to the particular cathode ray tube. See here, mainly electron gun, it will produce the beam of the electrons. That electrons will be moved from the based on the focusing system. That focusing system travel all the electrons into the maybe horizontal or vertical. Then these are the these are the go from assigned to the particular phosphorus being coated up instead of the particular CRT. When it will be hit into the phosphorus coated screen, then it will display the image on the particular screens. Okay. So this is the diagram of the cathode ray tube. See, The control gate voltage determines how many electrons are actually in the electron beam. The control gate controls the intensity of spot where the control beam is strike the screen. So the control gate is control the intensity of the particular whenever the electron beams are produced at the time of the electrons. Okay, in that way the control gate controls the intensity of the particular electron beam. Then it will be strike on the particular screens. So the focusing system will concentrate the electron beam so that the beam converts to a small point when it's hit the phosphorus coated screen. So whenever the electron beams are produced from the electrons, then all the all will be formed directly. In that way, it will the focusing system concentrate the electron beam so that the beam converts to small points when hit into the phosphorus coating system. Then it will display the image on the particular screens. So the deflection system of the CRT consists of two plates of parallel plates referred as the vertical and horizontal deflection plates. So next, whenever we apply the voltage to the vertical deflection of the electron beam and voltage also applied in the horizontal deflection controls the horizontal of the deflection of the control from the electron beams. There are two techniques used to produce the images on the CRT screen. Okay, so how to form the image on the particular CRT screen, you are using to the different type of the techniques. The first one is a random scan and second one is a raster scan. So random scan is also called as a vector scan. Okay, so mainly we are using to the two different techniques from the CRT when I produce the image on the particular screen. That is the random scan systems, and next one is the raster scan systems. Okay. See, raster scan displays. These are raster scan displays or raster scan displays are also available. Next. So random scan systems are also called vector displays, stroke writing, or calligraphic displays. Okay. So the electron will directly draw the picture in the any specified order. A penning plotter is an example of such system. So if you are to the penning plotter, that plotter will be assigned to the image on the particular screens. See, picture is stored in a display list, refresh display file, vector file, or display program as a set of line drawing commands. Whenever you store the picture of the particular display list, it will be using of the display files, vector files, or display program as a set of line drawing commands. And refresh rate depends upon the size of the file. Refreshes by scanning the list 30 to 60 times per second. So it will be refreshing at the each of the 60 times per second. More suited for line drawing application such as architecture and manufacturing. So mainly we are using for architecture and manufacturing. Rapid refresh rate on the random scan system depends on the number of lines to be displayed. So picture definition is now stored as a set of line drawing commands in an area of memory. It referred to as the refresh display file. Sometimes the refresh display file is called the display list or display program, or simply we can call as a refresh buffer. So whenever the image will display on the particular screen, and each and every time it will be referred to the on the particular 60 times for the screens. Okay, in that way we the image will display on the particular screens. So how we have discussed in the classrooms, so how it will be displayed, how it will be form of the image in the particular screens in using of the random scan systems. Next, to display a specific picture, the system cycles through the set of commands in the display file, drawing each component line the turn. After all the line drawing the commands have been processed, the system cycles back to the first line command to the list. So we are using the column wise row wise, then all the lines will be completed, then it will be refreshed, then it will go from the starting line. Okay, so in that we can say all the drawing line commands have been processed, the system cycles back to the first line command in the particular list. Next, random scan systems are designed for line drawing applications and cannot display the realistic shapes on the screen. So mainly related to the line drawing algorithms, but there is no realistic. Since picture definition is stored as a set of line drawing instructions and not as a set of intensity values for all the screen points. Okay. And also vector display produces smooth line drawing because the CRT beam directly follows the line path. So whenever user the CRT beam will be directly flow from the line wise, in that way we say that it will be producing the smooth line drawings. Next, a raster system in contrast produces jagged lines that are plotted as the point sets. C. So the runner draws the component lines of an object in any order. Likewise, so it will be draw the lines. Likewise, first it will draw the line, then next like that, then next, then it will display the image on the particular screen. So likewise, it will draw the lines. In that line we can define here the triangle. Okay, so likewise we have to display the image on the particular screen. In that we can say the random star systems are main displays are mainly used from the line drawing algorithms. Okay, next raster scan displays. So raster scan display is the most common type of monitoring using CRT. CRTs. A raster scan is a matrix of pixels covering the screen area and is composed of raster lines. So in the raster scans, we are based upon the matrix we can define on the pixels and we can perform the operations. See, the electron beam scans the screen from top to bottom, one row at a time. Each row is called as a scan line. So whenever we can draw the lines, that is each line we can call as a scan line. So already we have discussed what is the scan line, so how we will draw the electron beams like that. Okay. So the electron beam is turned on and off or produce a collection of dots painted on one row at a time. These will form of the image. When it will be draw the lines and that it will be produce the image on the particular screen. So whenever we draw the line, that line it will be on and off produce the collection of dots painted on one row at a time. Next, the most common type of graphics monitors employing the CRT is the raster scan display based on television technologies in a raster scan systems. The electron beam is swept across the screen one row at a time from top to bottom. As electron beam moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. Whenever you can apply the spots, it will be on and off, on and off. So how we keep on and off, we can already discuss on the classrooms. Okay, as electron beam moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. Picture definitely stored in the memory area is called refresh buffer or frame buffer. Whenever you can store the picture in the particular memory, it is called as the refresh buffer or frame buffers. This memory area holds a set of intensity values for all the screen points. So stored intensity values that deducted from the refresh buffer and painted on the screen one row at a time. Each screen point is referred to as a pixel or pel. So in the each screen you can define the different amount of pixel values in that way. In each spot is called as the pixel. See, that is called pixel or pel, and there is a shortened form of picture element. Pel is a pixel. Then a short form and అంటాము అని చెప్తాం. On a black and white system with 1 bit per pixel, the frame buffer is commonly called bitmap. It is called as a bitmap. For a system with multiple bits per pixel, the frame buffer is referred as a pixmap. So, in the systems you have multiple bits are applied, that way you can say that is called as a pixmap. Okay, pixel map. Okay, now see, these are all the scan lines. All lines are called as the scan lines. Based upon these scan lines, we can draw the image. We can draw the image like that. So line 1, line 2, line 3. So likewise, we have to draw the images in the raster scan systems. Okay. See, it will be refresh producing this ray tracing and interlacing. That is horizontal ray trace and vertical ray trace. In the horizontal ray trace, beam returns to the left of the screen. In the vertical, beam returns to top left corner of the particular screen. Okay. Interlacing means it displays the first even number of lines, then odd number of lines, and permit to see the image on half of the time. And the useful of a slow refresh rate is 30 Hz to the 60 Hz. So scanline section beyond visibility edges as there is a limit on speed of swept generator. Avoid rocking at borders and distortions. Top and bottom vertical over scannings. Left and right horizontal over scannings. So what is the refresh rate of a particular raster scan display? There is 24 is a minimum to avoid flickers correspond to the 24 edges. Each edge is a one refresh per second. And current raster scan displays have a refresh rate of at least 60 frames. There is a 60 Hz per second up to 120. Okay, so possible is 24, but it is mainly we are using to the 60 frames. Okay, there is 60 Hz to the 120 Hz. At the end of each scan line, the electron will return to the left side of the screen to begin displaying the next scan line. Then the return of the left of the screen after refreshing each scan line electron beam is called the horizontal retrace of the beam. And at the end of each frame, the electron beam returns with a vertical retrace to the top left corner of the screen to the beginning of the next frame. See here. So it will be draw this line, then it will be come from the first, then draw, when come it will go from the only left from the top corner. So likewise, we have to implement the lines or the master scan display system. Okay. So each and every line we can call as a scan. Next, in raster scan display, it is called as a frame buffer. That is, it is also called refresh buffer. Contain picture definition. The image stored in the frame buffer containing the total screen area and where each memory location corresponds to the pixel. See, for example, consider 2D where it is the frame buffer is 8 by 8. That is the color depth 8. There is a values are 0 to 7. Use large memory that is 640 by 480. That is the 33 lakhs 7,200 bits. That is 38 KB we are using to produce the image on the particular screens. So all the images are stored in the particular buffer that is called as the frame buffer or refresh buffers. Bitmap is a monochrome system. Each bit is 1 or 0 for the corresponding pixel to be on or off, making the frame a bitmap. The display processor scans the frame buffer to turn electron beam on or off depending on if the bits is 1 or 0. This is the example of the bitmap. Only we are used to the 1 and zeros. Different, difference is display mechanism. E-beam traces enter the screen from upper left corner to bottom, but E-beam can highlight the random positions. Drawing is the pixel and random is a line. Image is a frame buffer. It is called as a display file. An image can display very complex images also with great accuracy, but random system wireframing modeling image quality may be jogged due to the digitalization. Diagonal lines are produced with lower intensity. Smooth lines as even directly follow the line path. Diagonal lines are produced with the equal intensity. Refreshing. Entire screen has to be refreshed. Only selected portions are redrawn. Refresh rate is 80 Hz. There is a high refresh rate. Animations are support from the raster scan systems and displays, and the random displays cannot support the animations. In colors are high color depth, the raster scan displays, and there is no color high color from the random systems. Color technique is a shadow masking, and it is a beam penetration. The random system is the beam penetrations. Okay, so these are all the differences from the raster and random scan systems. Okay. So in the raster scan, we have different pixels. In the random scan, we have different lines. Next, color CRT. So a CRT monitor displays color pictures by using a combination of phosphor that emit different color light. It generates a range of colors by combining the emitted light from different phosphorus. Okay. Before we are discussing CRT is the normal CRT, there is the black and white. Now we are discussing the color CRT. When the CRT monitor displays the color pictures by using the combination of phosphors and depending on the colors that it will differ generate the range of colors by combining the emit light and produce the phosphoruses. So there are two basic techniques used for producing the color displays. First one is the beam penetration and second one is the shadow mask. So shadow mask is the raster scan and beam penetration is the random scan displays. Beam penetration technique. This technique is used with random scan monitors. In this technique, the inside of CRT screen is coated with two layers of phosphor, usually red and green. So all we are into the red and greens. The display color depends upon how far the electron beam penetrated into the phosphor layers. So whenever we have the electron beams are moved into the particular phosphorus layer, that based upon that speed, it will be define the different type of the colors on produce the colors on the particular penetrating. The outer layer is of red phosphorus and inner layer is of green phosphor. So we have seen the two phosphorus layers, that is the outer layer is the red and the inner layer is the green. Then the penetrance will be forming the layers beams of phosphate assigned to the particular phosphor tend to display the different type of the colors. A beam of slow electrons exits only the outer layer. A beam very fast electrons penetrates through red layer and exits only green layer. So it will go from slow, it will only produce the red layer. It go from the fast, it will be combined to the red and green layer. An intermediate beam with combination of red and green lights are emitted in additional colors. Orange and yellow is displayed. So in the intermediate beam, it will be display the four colors, that is the red, green, orange, and yellow. The beam electron acceleration voltage controls the speed of electrons and hence the screen color at any point on the screen. So in the advantages, it is an inexpensive technique to produce a color in random scan address. So and demerit is it can display only four colors: red, green, orange, yellow. Okay. So the quality of picture produced by this technique is not good as compared to the other techniques. Okay. The shadow mask technique produces a much wide range of colors than the beam penetration technique. Compared to the beam penetration, the shadow mask produces a different type of the colors. Okay. Hence, this technique is commonly used in raster scan displays, including the color TVs. In shadow mask technique, CRT has three phosphor color dots in each pixel position. That is, we can define the each pixel position three colors: red, green, yellow. One phosphor dot emits red light, another emits the green light, and third emits the blue light. Red, green, blue. Okay, that is called RGB. Okay, see, this is the color CRT shadow mask technique. See, this is the guns blue, green, and red gun. It will form the shadow mask. Then it will produce the each and every pixel. It will assign to the three colors, that is the red and green color. Then it will be display the image on the particular screens. Okay, so these are the color CRT monitors. It has three electron guns, one for each color dot, and shadow mask grid just behind the phosphorus coated screen. The shadow mask grid consists of series of holes aligned with the phosphor dot pattern. Three electron beams are deflected and focused as a group on the shadow mask, and when they pass through the hole in the shadow mask, they instantly dot triangle. A dot triangle consists of three small phosphor dots of red, green, and blue color. A dot triangle, when activated, appears as a small dot on the screen, which has color of combination of three small dots on the screen, which has color of combinations of three small dots in the dot triangle. By varying the intensity of these three electron beams, we can obtain different colors in the shadow mask CRT. So here in the dot triangle, this is the dot triangle. This is the dot triangle. It will be assigned the three colors. That is the red, blue, green, likewise. Okay. So a dot triangle activated a small dot on the screen, which has color of combination three small dots, and can define the different type of the pixels there in each and every pixel has the three colors. When it will produce the electron beam, the electrons will be touch hit into the particular screen. There is a particular layers, then it will produce a different type of the colors on the particular screen. In that way, we have the see the all the pictures in the colors wise. Okay, and by varying the three electron beams, we can obtain different color. The shadow mask of the CRTs. Okay, next there is a DVST. It's called as a direct view storage tube. So I have discussed what is the CRT and what are the CRTs. Now we can discuss the DVST, that is the direct view storage tubes. Okay. In DVST, raster scan display will do refreshing of the screen to maintain the screen image. But DVST give alternate method to maintain the screen of the image. So actually in the raster scan, we can refreshing the particular each and every. But here in DVST, already it will be assigned the particular method to maintain the particular screen images. Okay, so a device uses the storage grid which stores the picture informations. Okay, thank you.